my dear students, today we are going to start with a new topic which is atomic structure and elementary quantum mechanics. And this is one of the basic chapter in the physical chemistry part of the first year. So we will learn the structure of atom, molecules, and we will develop the quantum mechanical model for each particular atom. We will discuss all these things in this particular session. Now I'm going to explain you about the atoms and how the atom is particularly it is containing generally the protons, neutrons, everything I will tell you exactly what actually the electron, the whatever the rotation of the electron surrounding the nucleus, how it is rotating around the nucleus. We will discuss all these things here. And here the elementary quantum mechanics here. So that means elementary, the basic things of the quantum mechanics we will also deal here. So first of all, you need to understand the introduction of this basic atomic structure. And here the word the atomics, quantum mechanics is there. So why this particularly the quantum, the word which came here. So quantum mechanics, what is this quantum mechanics and how it is related with the classical mechanics. So generally the classical mechanics, generally it is studied in the physics that is proposed, that is given by the Newton or many scientists. So generally the classical mechanics is called as a Newton mechanics here. The quantum mechanics, it is proposed by the Schrodinger, Heisenberg. There are many other scientists here. But however, here we have to discuss in detail about the atomic structure here. So how atoms are there. So generally the atomic, the whatever the constituent particles are present in an atom here. So generally in the basic, so it your generally it your lower classes, generally you have studied the structure of atom. So you know that the structure of atoms it was given by first the Dalton, J.J. Thomson, Rutherford, Niels Bohr, everything. So many scientists, Niels Bohr. So whoever the scientist, so they given their postulates for the atomic structure here. So here in this particular session, I will discuss this atomic structure from the Rutherford model so that you can easily understand here. So first, let us understand the atomic structure here. So first, the basic thing, what are the contents here in this particular chapter here? So these are the contents here. See the classical mechanics and the quantum mechanics and the black body radiation, the UV catastrophe and the Rayleigh Jeans law, and next the Planck's radiation law, photoelectric effect, Compton effect, atomic spectra, Bohr's atomic model, de Broglie hypothesis, and the Heisenberg uncertainty principle, the quantum mechanical model of an atom, the quantum numbers, and finally the electronic configuration. So these are all these things in this particular atomic chapter here. But now this is actually very lengthy chapter. So actually in the syllabus you don't have all these things because all these are there in your intermediate level. You know you have already studied all these things at your earlier classes, that is the intermediate level. Now at your degree level, at your B.Sc level, generally in this particular you are having only these things, that is a black body radiation, UV catastrophe, and the Rayleigh-Jeans law, the Planck's radiation law, photoelectric effect, Compton effect, and the de Broglie hypothesis, and the Heisenberg uncertainty principle, and finally only these things are there in this particular at your B.Sc level. So at your B.Sc level you are having only these concepts here, that is black body radiation, Planck's equation, the photoelectric effect, Compton effect, and de Broglie hypothesis, and the Heisenberg uncertainty principle. But in detail, I will tell you all these things because every topic here is this very important part in the atomic structure. So if you understand well in this atomic structure, you can easily get through the physical chemistry part here. So because atomic structure is a basic thing here. So let us start from the atom here. How it particularly the atom is there. What is the relation with this classical mechanics and the quantum mechanics here? The word which is classical and the quantum mechanics here. So let us understand here. So the classical and the quantum mechanics, and we will deal with the. So let us start here the atom, and we will discuss the classical and the quantum mechanics. So first, so what is an atom here? So let us see first the classical mechanics and the quantum mechanics. So here the word the classical. So you know that the classical which is olden, it means that the classical it indicates it is olden here. The olden like classical dance. You know that the classical dance like Bharatanatyam, Kuchipudi, whatever it may be, those are the olden dance styles here. But here the classical mechanics are also it is one of the theory about the classical part. That means generally this classical mechanics it is related to the macroscopic system, and the quantum mechanics it is deal with the microscopic system. So what is here microscopic and what is macroscopic? Macro it is nothing but very big. It is greater than 10 to the power of 6. So it is greater than 10 to the power of 6. Generally it is called macro. Micro it is generally it is less than 10 to the power of minus 6 here. So here it is greater than this 10 to the power of 6 here. So you know this particularly macro nothing but it is very large. So the systems like sun, solar system like stars, moon, earth, everything we will deal all those things in the macroscopic study here. But in case of the quantum mechanics, we will deal with the microscopic level, as we will deal with the atoms, nucleus, protons, electrons. So we will discuss only these very small size particles here, like electron charges, whatever may be the quantum mechanics and the classical mechanics, both are completely different. So actually, from the olden days, the Newton. So Newton is a scientist. You know that the Newton mechanics, he whatever the theory, whatever the laws he proposed here, those are comes under the classical mechanics. So those are comes under the classical mechanics. So here the classical mechanics, he is given certain idea about the different solar system. So he is given many formulas or equations like Newton first law, second law, third law, everything he gave those laws, and those are completely applicable for the macroscopic system. So the classical mechanics is completely for the macroscopic system. So macro, nothing but very big, like solar system, sun, stars, and moon, like this. So, but this classical mechanics actually it is not applicable to the microscopic level. So, microscopic level it is not applicable here. So, according to the generally this classical mechanics, whatever the theory, whatever the formulas, so whatever the generalized equation that is given by the Newton, those are not applicable to the microscopic, different microscopic system. So generally like electron, so like proton, neutron. So these are very small microscopic, because atom is a very smallest part of the matter here. So but here these electrons or protons are the constituent particles of the atom here. That means here electron, proton are very small. That is which is less than 10 to the power of minus 6 here. So those are very small. They are called microscopic system. So whatever the rules, theories, generalized equation, laws, formulas, everything under the classical mechanics, they are applicable only to the macroscopic system. But they are not applicable to this such systems like electron, proton, neutron, the charge like species, so hydrogen. So whatever may be the small size micro, that is small size system here. So the microscopic studies, the classical mechanics is not approved here. So hence the quantum mechanics is came here. So generally so here the classical mechanics and the quantum mechanics, it is not like a single topic. So because the classical mechanics it includes many scientists here. So in the quantum mechanics there are many other scientists like Heisenberg, so Schrodinger. So there are many other scientists here like De Broglie. So there are many other scientists in the quantum mechanics, even Planck. So everyone, so more. So however, the many scientists are given certain ideas about the quantum mechanics and the classical mechanics. సో అంటే ఇక్కడ సడన్ గా క్లాసికల్ మెకానిక్స్ అనేది ఒక ఒక సింగిల్ డే లో మొత్తం రాలేదు, ఒక చిన్న టాపిక్ కాదు. సో ఇట్ ఈస్ వెరీ బిగ్ టాపిక్, మనకు చాలా పెద్ద టాపిక్. అంటే ఫిజిక్స్ లో మనం చదువుకుంటాం మైక్రోస్కోపిక్ స్టడీస్ లో సన్ సోలార్ సిస్టమ్ ఎట్లా ఉంది, దాని రేడియస్ ఏంటి, ఎనర్జీ ఏంటి, ఎవ్రీథింగ్, టెంపరేచర్, ఎవ్రీథింగ్ విల్ స్టడీ దోస్ ఇన్ ద క్లాసికల్ మెకానిక్స్. అదేమి ఒక్క రోజులో రాలేదు. మెనీ సైంటిస్ట్ సో వాళ్ళు రీసెర్చ్ చేసి దే హ్యావ్ గివెన్ సర్టెన్ లాస్, ఐడియాస్, దే ప్రపోజ్ డిఫరెంట్ పాస్టులేట్స్. సో ద జనరలైజ్డ్ ఈక్వేషన్స్ ఆర్ దేర్, దోస్ ఫార్ములాస్ ఆర్ దేర్. అవన్నీ మాక్రోస్కోపిక్ సిస్టమ్ కి మాత్రమే పనిచేశాయి. సో ఆఫ్టర్ సమ్ టైమ్ So at 18th century, 20th, 18th century, so whatever maybe, so there are other scientists who came forward to give about the idea of quantum mechanics, because the classical mechanics ఏవైతే formulas ఉన్నాయో those are not applicable for the microscopic particles like electron, proton. So hence here the quantum mechanics, the word came here. So the classical mechanics, it includes the macroscopic studies, and the microscopic studies it includes in the quantum mechanics. So you don't worry about this classical, quantum, everything we will discuss in detail in this session. So let us start from the atom, how the atom is there particularly first. So how atom will look like here. So how atom will look like, the atoms is very very simplest and very very smallest basic unit of matter. So that particularly atom. So what is an atom here? So let us take a molecule like H2. H2 is a hydrogen molecule. So hydrogen, it is H2. So that, let us take the gas of hydrogen here. So this is the gaseous molecules of hydrogen here. So now you can say how many atoms are there in this particular the gaseous substance here. So how many atoms are there? So that means there are millions of atoms are there. So you can, let us take water molecule. Let us take simple water molecule. If you take the 50 ml of water molecule, like 1 liter of water molecule, so how can you say how many water molecules are there in that particular 1 liter of water? So you cannot say like that. So in a 1 liter of water, there are millions of water molecules are there, not only single molecule. అంటే ఒక హైడ్రోజన్ మాలిక్యూల్ అంటే అందులో ఒకటే మాలిక్యూల్, అందులో ఎన్నో అటమ్స్ ఉంటాయి. సో H2O మాలిక్యూల్ 50 ml ఉంది, 1 లీటర్ ఉంది అంటే అందులో మిలియన్స్ ఆఫ్ వాటర్ మాలిక్యూల్స్ ఉంటాయి. మిలియన్స్ ఆఫ్ వాటర్ మాలిక్యూల్స్ అంటే మిలియన్స్ ఆఫ్ ఆటమ్స్ ఉంటాయి. సో H2 ఉదాహరణకు గ్యాస్ ఉంది. సో వాట్ ఎవర్ యూ కెన్ టేక్ ద లిక్విడ్ కాన్సంట్రేషన్ ఏదైనా తీసుకోండి. సో ఈ వాటర్ తీసుకోండి, 50 ml తీసుకోండి. 50 ml అంటే అందులో 50 మాలిక్యూల్స్ ఏం లేవు, అందులో మిలియన్స్ ఆఫ్ వాటర్ మాలిక్యూల్స్ ఉన్నాయి. సో మిలియన్స్ అంటే లాక్స్, క్రోర్స్ ఆఫ్ వాటర్ మాలిక్యూల్స్ ఆర్ దేర్. అందులో ఎన్ని ఆటమ్స్ ఉన్నాయంటే మిలియన్స్ ఆటమ్స్ ఉన్నాయి. ఎన్ని క్రోర్స్ ఉంటాయో అన్ని క్రోర్స్ ఆటమ్స్ ఉంటాయి. సో లైక్ దట్ యూ హ్యావ్ టు అండర్స్టాండ్ హియర్. సో ఫర్ ద atom is what? Atom is what here? So atom is a basic unit of matter with a dense nucleus at the center and surrounded by the cloud of negatively charged electron. So it indicates, you can see here, the atom is a basic unit of matter. So basic unit of matter here. So it indicates what, like you can take the pen or board, the human body. So human body is also a matter like that. So you can take a paper. Paper is made up of cellulose. So it is containing a chemical that whatever the molecule, the chemical containing, it is made up of certain surely an atoms here. So you can take many, whatever you can take, pen, paper, human body, everything. So human body, it is made up of millions of atoms here. So the particular human body, it is not only made with hydrogen, helium, lithium, beryllium. So it is made up of many such elements like hydrogen. So you can take the carbon, oxygen, zinc, chromium, titanium, whatever may be the metal or element which is present in the periodic table. But human body, it is a matter. So like wall, you can take the wall, goda తీసుకోండి, pen తీసుకోండి, chair, you can take anything matter. It is made up of certain atoms here. So the atom is nothing but it is a basic unit of matter here. So with dense nucleus, అంటే ఇప్పుడు ఒక గోడ తీసుకున్నాను. సో ఒక గోడ అంటే you can take simply, I will tell you one thing here. So you can take, let us take an example of, a chair. So you can take the chair. Chair ని మనం చిన్నగా చేస్తూ ఉంటే ఏమొస్తది అంటే ఫైనల్లీ యూ విల్ గెట్ ద ఆటమ్ హియర్. సో మనం అంటే అర్థం చేస్తున్నది ఏంటి అంటే యూ కెన్ టేక్ వాట్ ఎవర్ ద మ్యాటర్, ఏదైనా మ్యాటర్ తీసుకోండి, అందులో స్మాలెస్ట్ దాన్ని బ్రేక్ చేసుకుంటూ పోతే యూ విల్ గెట్ ద ఆటమ్ హియర్. సో మీకు వచ్చేది ఆటమ్ అని. సో ద ఆటమ్, so actually it consisting of a dense nucleus at the center. So particularly it consisting of a dense nucleus at the center. So there is a center, it consisting of a nucleus here, and here it is surrounded by the electrons, like it is surrounded by the electrons. So the electrons are surrounded by it around the nucleus here. And the dense nucleus, which is the central part, the dense nucleus, it is at the central part and surrounded by the negatively charged electrons here. So let us understand this atom here. So what is proton, electron, neutron, how many are there for each atom? We will discuss all these things here. So let us understand here first. So my dear students, so first let us build an atom here. So with the electrons, protons, neutron, everything here. So first let us understand here what is an electron, what is proton here. So atom, it is like this. So let us take the central part which is a nucleus here, and this is whole which is an atom here, and the central part which is a nucleus here. So you know that the electrons are surrounded by the nucleus, and these electrons are revolving around the nucleus like this. So you know that this particularly the arrangement of atom here. So let us go in detail with the electrons, protons, with the charge here. So whatever the particles present in the atom which is neutron, you know that this is a neutron, and you can take the proton and the electron. So these are the major particles which are present in an atom here. So where they actually located here. So what is the so where it is a position. So I need a position of this neutron, electron, and the proton here. So let us understand this. So here there are three types of subatomic particles are there. So what are the three subatomic particles are there? So one is electron here. So one is electron, and the next one which is proton, and the next one which is neutron. So you know that it was discovered by J. J. Thomson. J. J. Thompson. So, and this is Chadwick, and it is Goldstein. Goldstein. So nothing but these three are the scientists. So they actually discovered these three subatomic particles which are electron, proton, and the neutron here. So this electron generally, this electron is actually it is a negatively charged particle, and the proton which is positively charged particle, and the neutron which is neutral, that is a zero charge here. So let us understand this electron, proton, and neutron. So you can take, so let us understand here. So there is a circular part which is nucleus, and the atom which is a circular like this. So it is a nucleus. Let us understand it is a nucleus, and it is an atom here. So those are orbits like this. So let us take the electrons are like this. So they are surrounding around the nucleus like this. So they are the negatively charged particles like this. So they are the negatively charged particles. So these are called electrons here. So because electrons are always revolve around the nucleus, and it also they can rotate, they can also revolve on their according to their its own axis also. So here these electrons they can rotate, so they can revolve around the nucleus like this. So it is these are the electrons here. And where are actually the protons? Where are the neutrons here? You know that the protons and the neutrons, so these are called actually nucleons. Nucleons. So why they are called nucleons? Because they are present in the nucleus. They are present in the nucleus. So that means these proton and the neutrons, they are present actually in the nucleus here. So hence these particles are called nucleons. And here this proton which is always have the positive charge, and neutron which is have the zero charge. There is no charge for the neutron, hence it is called the word which is neutral here. So let us understand this. In each atom, in each particular atom like hydrogen, helium, lithium, how many protons are there, how many neutrons are there, how many are there, how can we know that? So that we can easily understand by seeing the periodic table. So in the periodic table, you will see the two words which is atomic number, and the second one which is atomic mass. So you will see these two words here. So atomic number is nothing but it is a number of protons, or we can say it is a number of electrons. Because in an atom, in every neutral atom, there are equal number of protons and the equal number of neutrons. So what is atomic mass? So atomic mass, actually what it actually mean here. So here you can easily understand here. So it is number of neutrons plus atomic number. So here I can say number of neutrons plus the atomic number here. So the atomic number. So atomic number, it again indicates the number of protons and the number of electrons here. So atomic mass, which indicates number of electrons plus protons or electrons here. So it is neutrons, sorry. Number of neutrons plus protons or electrons here. So generally the atomic number is indicated with Z and atomic mass is indicated with A. So let us understand here first. So in any atom, so I will draw again once again the atom like this. So let us say this is an atom and this is the central part which is a nucleus here. And particularly you know that, so definitely you know that the electrons are always revolve around the nucleus like this. So they will revolve like this. So this green color, which are the whatever the green color I have shown you, this is the electrons here. So next, I will show with another color for protons and neutrons here. So the proton, you know the proton, what is the charge of the proton here? So particularly the charge of the proton here. So what is the charge of the proton here? Generally the protons are positively charged species here. So they are present inside the nucleus here. So the white color, so I have shown you with white color with positive charge. These are called protons. And the negatively charged, which are called electrons here. And there are also the neutrons. So there are also the neutrons, so which are having the zero charge, that is neutrons. So they are also present inside the nucleus like this, neutrons like this. So so we will discuss the atomic number and atomic mass. So atomic number, which is equal to Z. So Z is equal to atomic number. So what is actually the atomic number? It is nothing but number of electrons or number of protons. So because always in every neutral atom, the electrons is equal to protons. So both are actually same. ఎన్ని electrons ఉంటే అన్ని protons ఉంటాయి ఏ atom లో తీసుకున్నా. That is Z. Next, atomic mass, which is equal to E or P, that is electrons plus electron or proton, because both are same, plus number of neutrons here. So this is the atomic mass here. So this is an atom containing three particles, which are electron, proton and the neutron. So always electron, which is having the negative charge, proton, which is having the positive charge, and neutron, which is zero charge here. So you can easily understand here the atom, it is a basic unit of matter, which is having a central dense nucleus at the center and surrounded by the cloud of negatively charged electrons here. So this is the atom structure here, basic structure of atom here. So don't worry, this is the only introduction of the atom. We will discuss how the electrons arranged. They can revolve around the nucleus in a circular path. So we'll discuss all those things here. So first of all, you should know that atom, it is a basic smallest unit and it contains three particles, that is electron, proton and a neutron. And always electron is having the negatively charged and proton, which is having the positively charged. And always in every neutral atom, the number of electrons, protons are completely same. So remember this, these two are same, but the neutrons are completely different. So that depends on again mass. So we'll discuss all those things here. So here let us understand here first. So let us remove all these things and I will show you so one diagram so that you can easily understand here. So let us build an atom by using this small image here. So see here. So this is a periodic table. You know that. So this is the periodic table here. So this is the periodic table. You know that. In this periodic table there are 118 elements are there. So now we will fill this 118 element. So you can take any one of the atoms, so and we will fill those electrons, protons, neutrons in a particular system here. So let us understand these things here. So first let us go with the hydrogen. So the hydrogen, you know that this is the atomic number 1. So hydrogen being the atomic number 1. So hydrogen atomic number is 1. So I will write with another color. So let's remove this. So hydrogen. hydrogen atomic number is 1 and this is 2 and this lithium 3 and it is 4 and it is 5 and it is 6, 7, 8, 9 and this is 10. The atomic numbers will be like this. So the first atomic number, so here the hydrogen. So let us go with the hydrogen. The atomic number which is equal to 1. So that means it is equal to number of protons or number of electrons because both are same here. So what is the number of neutron here? Again the atomic mass which is equal to 1. So atomic mass is nothing but number of protons or electrons plus number of neutrons here. But the atomic mass of hydrogen which is equal to 1 and here is also this is 1 and here this is 0. So there is no neutron in this particular hydrogen here. So let us build this first hydrogen atom here. So first let us take the hydrogen atom. So let us take the hydrogen atom by taking one electron. So I just now only I told you the number of protons which is equal to number of electrons here. So remember this. So first let us go with the protons and electrons here. So let us build one of the particular electron from here. So let us see here. So I will take this one electron and fill this here. So see here, it is completely filled in a particular orbit here. So now I should also build this with a proton here. So now I'm building this hydrogen here with one proton and this red color are protons and the blue color are the neutrons, sorry, electrons here. So see this hydrogen here. So you can easily understand here that is hydrogen which is atomic number is 1. That means here you can easily understand here number of protons and the number of electrons are 1. But the number of neutron which is completely 0. Because when you're adding this protons plus neutron, you are getting only 1. So you can easily understand this hydrogen mass of the hydrogen which is only 1 here. So to get the mass equal to 1, so that means the number of neutrons must be 0. Then only you will get the mass as 1 here. So this is a hydrogen atom. So this is a hydrogen atom. So let us take helium here. So first there is a hydrogen and you will get 1 and you will get that is 1s1, you know that. So next helium that is 2 and the next helium lithium 3. See here you can easily understand this is 1 and 2, this is 3, 4, 5 like this. So let us build those electrons here. So this is the hydrogen, okay, it is over. Then let us take the helium. So it is a second atomic number. So that means 2 protons and 2 electrons here. So let us build first these 2 here, 2 protons and the 2 electrons here. So let us build this with the 2 protons. So one is already there, so I'm using another one. 2 protons are there and the 2 electrons are there. So what happens here? So whenever 2 electrons are there and the 2 protons are there, so see here it is a negatively charged and the red color which is a positively charged, so that it gets balanced here. So it is a neutral atom. So see the what is the formula, what is the element which is helium here. So because the helium which is having 2 electrons and the 2 protons, hence it is equal to helium here. Now let us again add another electron like this. So again I am adding another electron and here also I am adding another electron like this. So see there are 3 electrons are there. So what if it is atomic number is 3? So lithium, because atomic number is 3, that means you know that it is 1s2 and the 2s1. So I will tell you exactly the how to fill up the electrons in an atomic orbital. So I will explain you later on, but you have to understand here. So that is this is the lithium here because it is having 3 protons and the 3 electrons here. So see here you can easily understand this. If I am adding another electron, so let us remove all these things. So let us remove all these things. So first let us take another atom. So like I will add another electron here. So let us build a proton. ఇంకొక proton యాడ్ చేయండి. సో అట్లనే ఒక electron యాడ్ చేయండి. So what happens here? So now again you are getting what you are getting actually here. How many electrons are there? So here this is actually 1, 2, 3. Actually it is 4. So that means it is actually 4 means that is a beryllium. This is not lithium which is beryllium. So you can see you can add any other electrons. So I'm adding again electrons here. Again I'm adding electrons here. See here the electrons. and the proton. See here what happens here. So what is happening here? So you can easily understand here. The blue color are there, the electrons here. So how many are there? 3 plus 3, 6. 6 electrons means the atomic number is 6. So atomic number is 6. That means that 1, 2, 3, 4, 5, 6. That is the carbon here. So here this carbon which is having the number of electrons as 6 and the number of protons are also 6. So you can see here the particularly the protons are also 6 here. So this is a general atomic structure here. You can easily understand here. So particularly you have to remember one thing here, that is, so see here. So you must know here this particularly the term which is, so that is, I will show you with another color. Okay. See here. So here you have to remember these three things. So one is electron and the another one is proton and the last one which is neutron here. And this is E and this is P and this is N and this is a negative charge, this is a positive charge and it is 0 here. There is no charge here. And you can easily understand this. So electron here, it is completely revolve around the nucleus and the proton which is present inside the nucleus and neutrons are present in the inside the nucleus here. So this is the general atomic structure. So basic atomic structure unit here. So let us understand here the continuation of this. So let us take, so let us start with the theory. So first actually the Dalton. So you know that the Dalton is a scientist and he first proposed certain idea about the atomic structure here. So first he told on a particular statement. So he given a particular fact, particular postulate about the atomic structure, and he told actually like this: all atoms are indivisible. Indivisible. That mean what? Indivisible. So you cannot divide the atom here. So how why you are, yeah, why you are not, why you are enabling, so we are not unable to divide the particular atom. So why, what is the reason here? So because you have to understand that. So Dalton he told that the atoms are indivisible. So that means atom, it is the smallest part of the nucleus. You cannot divide that particularly atom because it is very very smallest atom. అంటే ఒక బిల్డింగ్ కడుతున్నాం అనుకోండి మనం. సో లెట్ us build a home. సో ఏదైనా ఒక బిల్డింగ్ కడుతున్నాం ఇట్లా. సో let us build a house like this. ఒక ఇల్లు ఏదైనా బిల్డింగ్ కడుతున్నాం అనుకోండి, ఇందులో బ్రిక్స్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్ హియర్. సో హియర్ ద బ్రిక్స్ ఆర్ నథింగ్ బట్ దీస్ ఆర్ ద స్మాలెస్ట్. సో స్మాలెస్ట్ మాటర్ హియర్. సో ఈ బ్రిక్స్ లేకపోతే ఆ ఇల్లు రాదు. So smallest, so these are the bricks. And this is the smallest unit. And you cannot again break down this bricks into another brick. And then break చేసి ఇంకోలాగా యూజ్ చేయలేము. సో ఆ బ్రిక్ అంటే అంతే, అది అయిపోవాల్సిందే. సో హియర్ ఆల్సో ద ఆల్ అటమ్స్ ఆర్ indivisible. Dalton ఏం చెప్పాడంటే indivisible అని చెప్పింది. But here, after that, many other scientists, so discovery of the electron, proton lead to the failures of Dalton atomic theory, and it leads to the discovery of Thompson atomic model. So you can easily understand here. So he told that Dalton told that atom is a indistinguishable substance, at indistinguishable a particular atom here. So that means atom you cannot divide. You can't divide the particular atom here. Hence it is indistinguishable or indivisible here. But the later on many scientists, so they discovered the electron, proton, and the neutron. So if they discovered these subatomic particles, which are even we can divide the atom into the constituent particles like electron, proton, neutron. So this comes under the failure of Dalton's theory. So Dalton theory ఏం చెప్పాడంటే atom అసలు విడగొట్టలేము అని చెప్పింది. But many further scientists, they they came and they divide the atom ని divide చేసి, so they can give the terms like electron, proton and neutron. So the discovery of these substituent particles, they will lead to the failure of the whatever the theory. So that is a Dalton theory. And let us understand this. So after Dalton, many other scientists, so they came with different ideas here. So let us understand the next theory. So after this Dalton, there are many other scientists, not only particularly Dalton. It is a he is a basic the first scientist here. So let us understand here. So let us go with the Thompson model. So after the Dalton, actually, remove all these things. So see here, after the particularly generally the Dalton, the next scientist who is Thomson or J.J. Thomson, he actually proposed, he discovered the electron here. So the discovery of electron is a failure of the Dalton model. Dalton, he told that atom is indivisible, but Thomson, he proved that electron we can make electron, proton, neutron from the particular atom. So atom can be divided into different particles, many other particles, but exactly like electron, proton, and the neutron here. So let us understand this Thomson atomic model. So he told that atom consisting of a positively charged particles and the electrons are embedded in it. So that means atom is a constituent consist of a positively charged particles. So atom లోపట ఒక positively charged species ఉన్నాయి. Positively charged species are there and the electrons are embedded in it. So electrons దాని లోపల ఉన్నాయి అన్నమాట. So here you can easily understand here. So Thomson, he told that, so there is something positively charged in the particular atom, the electrons are surrounded in it, and you can easily understand here that the magnitude of positively charged and the negatively charged in an atom is equal, hence the atom as a whole electrically neutral here. So this Thomson, the difference between the whatever the Dalton and the Thomson, it is only one thing. That is Dalton, he told that the atom it cannot divide it, but Thomson he divided, and he gave certain terms like the particles like electron, proton. So now currently the different particles like boson. So there are many other particles, but generally we will discuss only the electron, proton, and the neutron here. So that is the thing here. This is the Thomson atomic model. But each remember that every theory is have certain limitations here. So this particularly the Thomson model, it is also having certain limitations here. So see here the after the Thomson atomic model. So next the Rutherford is there. So Rutherford, he is another scientist. So he gave certain ideas about this particularly. So this particularly the atomic structure here. So he told that the whatever the Rutherford. So he told that. So what actually he told? So see here. So let us understand this Rutherford here. So Rutherford, so he uses a foil experiment here. So he told that particularly. So what are the details? What are the facts about the atom? So that he explained the Rutherford, and see here what actually he explained about an atomic structure here. So first he told that most of the positively charge is present at the center of the atom here. So he told that, so generally we are discussing about the results of Rutherford experiment here. Rutherford అనే అతను ఈ రీసెర్చ్ చేసి కొన్ని ఎక్స్పెరిమెంట్ చేస్తే కొన్ని రిజల్ట్స్ వచ్చినాయి. సో ఆ రిజల్ట్స్ ఏంటో చూడండి ఇప్పుడు. మోస్ట్ ఆఫ్ ద పాజిటివ్లీ చార్జ్ ఈస్ ప్రజెంట్ ఎట్ ద సెంటర్ కాల్డ్ న్యూక్లియస్ హియర్. అంటే మొత్తం ఆటం తీసుకుంటే అందులో అక్కడక్కడ పాజిటివ్ చార్జ్ ఉంది అని జేజే థామ్సన్ చెప్పిండు. But here the Rutherford, he told that most of the positively charge are present at the center. Center లో మాత్రమే ఉంటది. మళ్ళీ ఇంకెక్కడ పాజిటివ్ చార్జ్ ఉండదు. ఓన్లీ సెంటర్ లో మాత్రమే పాజిటివ్ చార్జ్ ఉంటది. He told that the nucleus is surrounded by the electrons through a circular orbit here. So electron is moving like this in a circular orbit like this. So like this. So these are the Rutherford foil experiment, the results here. So what are the limitations of this Rutherford experiment here? So you have to understand those limitations also here. So see here, what are the limitations here? So this Rutherford, he can't explain the stability of an atom here. And if both are oppositely charged, they could be integrated entirely here. So here you can easily understand this. So in a Rutherford foil experiment here, you can easily know that. So here the stability of atom, so he cannot discuss here. So because in this particular Rutherford, he told about the nucleus. So the nucleus is at the center of the atom here. but he didn't explain the stability of an atom. If both are oppositely charged, they could be integrated entirely. And there is also another, which is one of the foreigner, one of the person, which is Maxwell. So he also told that any charged particle, so any charged particle, so see here, any charged particle during acceleration must emit radiation so that possibly electrons should fall on the nucleus, but it is not taking place here. So that you should understand here. So I just now only I told you that there is a centrally which is a nucleus, and the electrons are revolving around the nucleus as a circular orbits like this. So he couldn't explain the, so he couldn't explain the stability of an atom. According to Maxwell, he told that any charged body, any charged particle like negatively charged electron is a charged body. So this particularly charged body is, it is under the acceleration. So it must emit radiation so that possibly electrons should fall on the nucleus, but it is not taking place here. So we will understand all these things here. And in Rutherford, he cannot explain the stability of an atom, and he didn't explain the energies of electron. He didn't explain the atomic spectral line, everything. So, but Rutherford is very, very important because he only proposed that the nucleus is present at the center. Nucleus is present at the center here. So that is a Rutherford foil experiment here. So after this, we will learn the Bohr's model theory and the quantum mechanical model. We will discuss these theory in the next session. So till now, you have seen the simple atomic structure here. So the atom, how it is made up of, how, what are the constituent particles? So what it is made up of? So generally, it is made up of only three particles here. So those three particles are protons, those protons and the neutron and the electrons here. So these three are the constituent particles which are very, very important here. So the protons and the neutrons and the electrons. We have to observe these three things here. Proton, which is a positive charge and it is zero, and electron, which is a negatively charged particle here. So now here in the next session, I will tell you exactly the Bohr's model theory here. Because so till now we have seen only the basics of the atomic structure, like atom in atom, what happens here. So now we'll discuss the two theories for the atomic structure. One is Bohr's model theory, and the next one, which is the quantum mechanical model of an atom here. So these are the two models for the atomic structure here, which are a very, very important thing here. So I will tell you the Bohr's model theory, and we will discuss those things in the next session. Okay, thank you.